All right, welcome back. From position vectors. We should note that we have the coordinates xi, yi, and then zi. These are our position. These are positions on space x, y, and then z. If we want to find the distance of r1 in respect to all these coordinates, the formula is r1 equal x1 I cap. Now, the reason why we are having this I cap is because R1 is actually a vector quantity. It is actually the displacement from the point of origin to where the particle is. And then X1 is a scalar quantity. So to make it a vector quantity, then we need to bring a vector unit. And that's what we have in high here. Plus Y1, next vector unit will be J, plus z1, the next vector quantity will be k cap. So if we have r2, it applies x2 I cap, y2 j cap, z2 k cap. So it means remember that r1 r2 is the distance from the center of origin to where the particle is. So if we have multiple particles, it means we can have multiple displacements. So I'm just going to give a general formula. Ri cap equal xi I cap plus yi j cap plus zi k cap. So if I'm having up to 5 particles, I just need to just put 5 here and then 5 here, 5 here, 5 here. You understand? All right. So what about the center? The center of the mass, the distance, is just the same thing. Cm equal xcm I cap plus ycm j cap plus zcm k cap. So in general, this is what we have now. Back to the first equation we wrote, the very first equation we wrote, which is this. We just write the general formula using the position vector and then write the general formula. So therefore, RCM equal summation of n I equal 1 m high ri over the summation I equal 1 and then m high. So this is the general formula. Okay, let's dive into questions now. All right, question 1. 3 masses are placed on the x-axis. M equals 0.2 kg at x equal 0. Let's solution. M1 equals 0.2 kg at x1 equal 0. It means M1, the mass of the particle is 0.2 kg. The position of that particle is at the 0 point of the x-axis. And then M2, 0.5 kg at x equals 0.30 meter. It means M2, 0.5 kg, and the position is corresponding position for M2 is 0.30 meter. And then M3 equals 0.4 kg at x equals 0.70 meter. All right, so it means the mass of the third particle is 0.4 kg, and the corresponding point for it is actually 0.70 meter. Now we are asked to calculate the center of this system. Now you note that we're just talking about the x-axis, so we don't need the y and we don't need the z-axis. It's just a point. So now the general formula is xcm equal the summation I equal 1. Now I is an integer, it can take any number from 1 to infinity. Okay, so we have x1 m1 over the summation of I equal 1 and m I, sorry, hi. So now the next thing you need to ask yourself is, having known this formula, you ask yourself, how many mass are we talking about? We're talking about 3 masses, and then for each of those mass we have the position vector. So I'm going to expand this formula in respect that I equal 1, I equal 2, and I equal 3, just 3. So it will now become xcm equal x1 m1 plus x2 m2 plus x3 m3 over m1 plus m2 plus m3. I believe you're following. Aha. So because we just have those 3 of this, now the next thing is just to substitute in the value. x1 here is 0 times m1 here is 0.2 plus x2 is 0.3 times 0.5 plus, and put it in brackets, 0.7 times 0.4 over the sum of the mass 0.2 plus 0.5 plus 0.4. So this is what we have. Right, after simplifying everything, xcm equal 0.39 meter. All right, the reason why I have to put it in brackets is some of us we can be tempted to just say 0 times 0.2 is 0 plus this. No, we just need to follow the order, board maths. We just need to multiply before adding. So now that's the final answer for question 1. Let's solve the next question. Right, question 2, this is what we're having, and we are asked to find the center of mass of this particle. Right, the first thing we need to do is actually to help us solve it. The thing we need to do to make it very, very simple is let's allocate each of the position. So at the origin, the position is 0, 0. That is and also let's say this is m1. So if this is m1, this is x1 comma y1, and then this become m2 at this position. Now look at it, it moves from the point of rest, that is the origin, to this distance, which is 1 meter. And notice that this is the x-axis, not the y-axis. So at this point, y is 0, x is 1. The movement is only at the x-axis. So I'm going to put 1, 0. Nice. X2, y2. I hope we know why it's x2, y2, because the mass here is m2. You can title your mass with anything. So let me say this is m3. Now, what is the coordinate of this point? You can pause the video and then try. Okay, at this point, x moves from 0 to 1. So at this point, it is 1 for x. At this point, y moves from 0 to 1. So at this point, it is 1 comma 1. All right, so let's say this is m4. The coordinate for this from here, this is the origin. So at this point, x has no value. The only value we have here is y, which is 1. Aha. So this is what we have. Okay, let me put x3, y3. Let me put x4, y4. Now, if you can successfully do this, then it will be very, very easy to calculate. Right? So we are having two positions now. We have the x and the y, not just the x as the first question. So we're going to write the general formula for x, solve it, write the general formula for y, and then solve it. Right, this is the general formula for x, and this is the general formula for y. So the next thing is, ask yourself, how many particles are we looking at? We're looking at 4 particles, m1, m2, m3, m4. So if we're looking at 4 particles, then that means we're looking at 4 positions in which those particles rest on. So we're going to expand this. I equal 1, I equal 2, I equal 3, I equal 4. So this is what we're going to have for x. Remember, I told you need to consider the number of particles we have. All right, let's go in and substitute the value for m1. M1 here is what? 4. I'm going to write 4 times the position x1 here is what? 0. Plus, let's go to m2. M2 here is 3. Sorry, times the position here x2 is what? 1. Plus, let's go to m3. M3 is 2 times the position there is what? 1. Plus m4 is 1 times the position there is what? 0. Over the sum of the mass, that's 4 plus 3 plus 2 plus 1. I hope you understand. So we're going to simplify this and then write the final answer. Right, after simplifying, xcm equal 1 over 2. The same thing we're going to do for the y position. So ycm equal m1 y1, m2 y2, m3 y3, m4 y4 over m1 plus m2 plus m3 plus m4. So we're going to substitute the value for each of this point. Don't be tempted to write the same thing you wrote for x for y. It can be very, very different. m1 here it's 4. The mass is not changing, the position changes, times y1 here is 0, plus m2 here is 3 times the position here is what? 0, plus m3 here is 2. All right, 2 times the position there is 1, plus m4 is 1 times the position there is 1 over the sum of the mass, that's 4 plus 3 plus 2 plus 1. Then you simplify it and find the final answer. Right, after simplifying it, we have y3 at 0.3, ycm at 0.3, and then xcm at 0.5. So it means that the center of the mass xcm YCM as actually 0.5, 0.3 meter. Okay, so let's try and thus guess where the position will be in our diagram. So x is 0.5. 0.5 should be around this midpoint, and 0.3 for the y-axis should be around this point. So I can just use my meter rule and trace this position. So the center of mass is around this position, which is 0.5, 0.3. And that's all about this question.